So here what we're going to do is calculate the corresponding confidence interval for the parameter mu. Now, when we say corresponding confidence interval, we mean it's corresponding to a hypothesis test. We don't always have to compute the corresponding confidence interval, but we'll go ahead and do it here just as an example. We'll assume that alpha is 0.05 in our hypothesis test. So what we're going to do first is calculate the confidence level for the corresponding confidence interval. And whenever you have a one-tailed test like this, the confidence level is 1 minus 2 alpha. All right, now how do I know this is a one-tailed test? I know it because when I look at the alternate hypothesis, it is in one direction. Mu is greater than 5. That's one tail. It's the right tail of the distribution. What would a two-tailed test look like? It would have something like mu not equal to 5. If it's not equal to, it could be greater than or less than. So for a one-tailed test, the corresponding confidence level is 1 minus 2 alpha, which equals 0.90 or 90%. So the confidence interval on the mean of the population mu is given by x bar plus or minus z times sigma over radical n. There's the formula. Let's plug in the values. 5.6 plus or minus 1.645 times 1.2 over radical 35. That gives us the interval 5.27 to 5.93. Now you might ask, well, where did I get the 1.645? The 1.645 is the z value from the distribution, the normal distribution. Now you can look that up in the table. So, you can kind of look here that z is 1.645. So you look in the table in the back of your book, you look at the very bottom of your table, and actually it's the T table, and we've used that before, but you get 1.645. Now, how do we interpret this? Well, here's what we're going to do. We're going to say we are 95% confident that the true value of mu, the mean of the population, is in the interval. In other words, the interval supports the conclusion we made in the hypothesis test, which was to reject the null hypothesis, if you recall, and accept the alternate. And, you can see this because you'll notice that the claimed value for mu, which is 5, is not contained in the interval.